let's look at a simple example of public goods and the efficient provision of public goods. So we're going to consider a very small society where we have a factory. All right, it's got, this is the door to the factory. There's some windows, right? Pretty sophisticated. And we have some pollution from this factory, talking in this case about air pollution. And look at this. It's devastating. Add some green. Colorblind. That looks exactly the same as blue. A little bit of yellow. Anyway, factory. Let's label it. We shouldn't be required to remember if that's a factory. We can label it. There are two nearby households. All right, little modest homes. Frugal Americans. Like Americans used to be. Where frugality was a trait that we admired. Back in Ben Franklin's time. And this kind of looks like a little centrally planned. Well, look at, to prove it's not centrally planned, everyone has their own creative abilities in this town. They pop the chimney on the other side. Let's take away those chimneys, not to confuse us with other polluting. So now they're pretty much identical. Anyway, these people, these households, are the recipients of this pollution. You can see it's kind of, you know, it's like dumping down on them. Whatever it is. It could be, you know, sulfur oxide, or we could even just be talking about something that is like a paper mill and it's bad smell. Whatever, there's an externality and it's pollution. And so the flip side of that would be cleaning up that pollution, abatement. That's what we're going to talk about. So you can consider our two households. This is our little society we care about. And each of them has a different value of cleaning up this pollution, right? They have a different marginal willingness to pay to reduce the pollution that's coming into them from this factory. Sorry. So I have it written down here, the two marginal willing to pay curves, right? So we'll call this guy household A and this guy household B. And I don't want to draw in front of my face. So the marginal willingness to pay for A, pink is not showing up as good as I'd like it to. Marginal willingness to pay, again, this is for pollution control. Public good. You can't prevent someone from enjoying a cleaner environment. It's 20 minus 2Q. All right? The marginal willingness to pay for household B is 10 minus Q. All right? And in terms, so again, this is what they're willing to pay. It's decreasing in the units of Q, which means that they're valuing those first units of abatement higher than the last units of abatement. And that should make sense. Just the law of demand here. And again, we speak about it differently because it's a public good and not a private good. All right. So we have the marginal willingness to pay for each of our households to reduce emissions. And we also have a cost. You could think of put your policy hat on. You're trying to maximize the net benefits, efficient provision of a public good to society. There's going to be a cost to cleaning up the environment. And the marginal cost is 2Q. That was estimated that for every unit of abatement Q, we're multiplying by 2. That's going to be the cost of the margin. Okay, the marginal cost, sorry. Trying to get that a little brighter. So we have our marginal benefits, we have a marginal cost, and we can now think back to the efficient provision, and we're thinking back to Paul Samuelson, right? And the Samuelson condition for the efficient provision of public good is where the sum of the marginal willingness to pay function equals the marginal cost, right? The cost of cleaning up equals at the margin equals the benefit at the margin, right? The marginal willingness to pay for everyone. In this case, it's only our two people, but you know, expand your horizons. Think beyond our two household town and think of billions of people. It's the same thing. All right? So what do we need to do to figure this out, to use Samuelson's concept and find the optimal Q? We've got to sum our marginal willingness to pay. So sum MWTP. Hope it's showing up. It's not showing up great. What kind of markers are these? Shake me. Huh. I never read it. It says shake me. I was hoping to be just blown away, you know? Like, didn't happen. And so, okay, I'm summing these, and I'm looking at 30 minus 3Q, right? Remember, summing these marginal willingness to pay, we call this summing vertical summation. This is vertical summation. And why? Because these monetary values, right, prices or willingness to pay, are on the vertical axis when we're graphing these. And so when we're summing things over these willingness to pay, right, over these values, this is a vertical summation. Where a typical, you know, if we have people who have demand curves and we add them up to get market demand, that's a horizontal summation. We would solve for Q, because everyone has, you know, because these goods are rival with private goods. Once I consume this, it's not available for someone else. So we sum over Q, and that's a horizontal summation. Anyway, we've done this right. Now we can compare it to marginal cost. And so the Samuelson condition says the optimal, the efficient provision of the public good is where 30, well, is where marginal willingness to pay, the sum of it equals marginal cost, and 5Q, and Q equals 6. All right? And so 6 would be, again, the units of abatement, whatever, metric tons. You know, this is a stylized example. Who knows what that means? But this is the point, is that 6 is going to be the level of abatement that maximizes the net benefits, which is the efficient provision of this public good. Now, it's not like we're going to ask these people to pay this or whatever. We could imagine the taxation system. But the point is that this is what would be efficient.